I think that it's not thought about often enough as a climate change adaptation tool. I mean, it's thought of more frequently as a mitigation tool than as an adaptation tool. And of course, there are benefits to carbon sequestration in forests. I'm not trying to argue that that's not a viable use of forests, but one shouldn't miss the opportunities to also influence hopefully in a beneficial way, the hydrologic cycle. And since trees contribute dramatically to the hydrologic cycle, it's important to consider that. They both take water away, but they also add to precipitation and runoff in other locations. And so as long as one thinks about that carefully, and thinks about the geographic relationships that are important in that regard, one, I think, can apply them as climate change adaptation tools.
Can we predict enough to know if there's drought in this area, where to plant trees to increase the rainfall?
It's a good question. I've troubled a lot with this idea of, how much forest do you need in order to produce a rain cloud over the next region, and I don't think that there are any simple answers to that problem. Obviously, you need a lot of forest to be able to have some kind of a positive impact on rainfall patterns. But I do think it's possible to afforest large regions and to have a significant impact on precipitation in other locations. And certainly one area where I thought a lot about this initially was in Hungary, where I work, where one of the big questions is what's going to happen to the more agricultural region as climate change continues. The predictions are not very positive in terms of how much higher temperatures in summer, much lower precipitation in summer. And so the question is then, how will agriculture in that area survive? And I think a lot could be done with afforestation, in particular in the southwestern region of Hungary, because that is essentially the way in which the wind currents go. And so you could take a lot of that AT from the increased afforestation, and hopefully some amount of that ET would then contribute to precipitation over the agricultural regions. And evapotranspiration, that's correct. And actually, I just recently, say a few months ago, came across a study which essentially came to precisely those conclusions. Somebody had gone and done an analysis with global climate modeling to try and predict the same kind of thing, and that was essentially their prediction. And it was also interesting to note that they predicted that the increased forest cover would have the least impact in the southwest region. So there would be less of a positive impact on precipitation and runoff in that area, which is exactly what I would predict. I mean, the ET that is produced, the evapotranspiration that is produced in one region, impacts positively other locations.
So that's why, in terms of from the policy point of view, things need to be done at quite a national level.
They certainly need to be thought about very carefully at higher levels. I mean, you can't just think about this in terms of individual catchments. You have to think about much larger regional relationships. And you have to think carefully about how all of the different areas of a region are interlinked in terms of the cross-continental transport of moisture vapor.
Because one country could afforest an area, but another country could be
Absolutely. So, it's like Germany is, as an example, with very, very low forest cover nationally. That's presumably had a big impact on precipitation further inland, actually across quite a large expanse. If you look at, say, catchment level studies, what they have consistently shown is that if you plant trees in those catchments, they will take water away. So they don't just produce precipitation, right? They put water from the ground, the soil, or and they put it out into the atmosphere. So trees have this impact of actually taking water away, not just of producing precipitation. But of course that ET comes down somewhere else, that evapotranspiration, as precipitation. And when we look at, let's say, what are the sources of precipitation, as in the study that I did for the major river basins of the world, it's possible to sort out what parts come from oceanic evaporation, what parts come from evapotranspiration from terrestrial surfaces, and then from one or two other sources. And evapotranspiration from terrestrial surfaces is a very large component. On average, about 50% in summer, so on average across the globe, or in these major river basins that we looked at, or we had data for, and 40% on an annual basis. So we know that the sources of precipitation are in part from evapotranspiration, and then the next thing that we also know is that trees, forests, are among the are the most important, the most efficient evapotranspirators out there. So if I compare them, say, to crop cover, agricultural land cover, they can evapotranspirate about twice as much as agricultural crops will, or about twice as much as water body surfaces will evaporate off. So they are big contributors, and so removing forests will have the biggest impact on cross-continental transport of moisture vapor.
Can you explain in one sentence what evapotranspiration is?
Evapotranspiration is two things. It is, so trees, when they are growing, they use water which they transpire into the atmosphere. That is the transpiration component. And then trees intercept rainfall from hitting the soil. It lands on the leaves and it is evaporated into the atmosphere by warmth from the sun. And so the two together are essentially considered or called evapotranspiration. I certainly hope that more thought will be given to it as a climate change adaptation tool. I think you can have an important impact on water availability in a lot of regions. And the example that I mentioned for Hungary, of course, is just one among many, where, let's say, across all of the southern regions of Europe, we expect in the summertime in particular to see very, very high, much higher temperatures and much lower levels of rainfall. And that's a common finding across a lot of areas. In the northern areas, we don't expect quite the same thing. We expect more rainfall rather than less. But in many areas, it looks like it could have a very important impact.